Hey everyone, my name is Adam Dixon, and welcome to my YouTube channel. Today we're going to be discussing neural networks. Enjoy some woodworking in the background. So what is neural networks? In the meantime, I want you to digest this sloppily written, poorly rendered, and extremely low resolution 3, 4, and 5. But despite these, you can recognize these effortlessly. Take a moment to appreciate how remarkable that is. Despite the differences in pixel values between these images, your brain interprets them as the same concept. But after you write them down to do the same in a program, the task becomes dauntingly difficult. Neural networks have revolutionized technology. But what is a neural network? In this video, we'll break it down, starting with its structure. In a neural network, a neuron is simply a container for a number between 0 and 1. For instance, when processing an image, each neuron corresponds to a pixel's grayscale value. Here we have neural network layers. The network starts with 784 neurons for a 28 by 28 pixel input image. These connect through hidden layers to the output layer, where 10 neurons represent digits 0 through 9. Each layer builds on the previous one. For example, a neuron might detect a loop, while another detects a vertical line. Take a moment to write some notes. Together, these patterns indicate the digit 9. As you can see, another poorly drawn, sloppily written 9 is being put together, each indicating a different part of that number. This layered approach enables a neural network to recognize complex patterns. Neurons are connected by weights, numbers determining how strongly one neuron influences another. A weighted sum is calculated and passed through a function, like a sigmoid function here, to process an output between 0 and 1. Training involves tweaking weights and biases to recognize patterns in data. With 13,000 parameters in this next network, it's a complex but fascinating process. Neural networks excel at breaking down tasks into layers of abstraction. From detecting edges in images to parsing speech into words, the potential is vast and immense. Right here, we're showing a neural network with weights being connected positively and negatively with red and green lines. While sigmoid functions were initially used, modern networks favor ReLU. We'll discuss that in the next video. What ReLU does is simplifies training and performs better in deep networks. A neural network is at its core just a function, a highly complex one, built to recognize patterns. By understanding its structure, we gain insights into its learning processes. Here, we have a complete neural network structure. The example is showing an input of 8 flowing through to produce a correct output. The green values again indicating the weights that are being accepted, while the red are being denied. Eventually, as each part is slowly connected to each other, the entirety of the image will be parsed by the neural network. Here's some rendering. As you can see, we have 782 and an 8 being parsed through. Green being, again, accepted values that will be passed on to the next set of nodes, while red being denied and stopped in their tracks before being realized by the neural network. This process is extremely quick and almost impossible for a human to react to. The small parts being formed here by the green lines create the value 8. Let's wait and watch as you take notes. Look to someone next to you and tell them what you think about what you're seeing right now. This is what a neural network looks like. There is one hidden layer here in this specific neural network. And the output layer, which is indicated by a 0, a 1, a 2, 3, 4, 5, 6, 7, 8, our output value, and a 9, the 10 layer, the 10 individual numbers for the output. Think about the output values. If you have any questions, rewatch the video and leave a comment down in the description. Thank you for watching. Check out my channel for more educational videos.